Okay, here's your overview for the properties of alkanes, topic C7, lesson 2. So the alkanes are hydrocarbons, again made from only hydrogen and carbon. Let's remind ourselves that hydrogen can form one covalent bond and the carbons can form up to 4 covalent bonds as well, and that helps with our structure. Now there's two main structures that the alkanes can form. We can have chains, which we've seen before in lesson 1. That's when basically we line all the carbons up and we have all the hydrogens connected up and down, left and right. And then we also have a ring structure as well, which we don't tend to look at too much, but they can form chains and rings. So we get our carbons forming a circle here, and we've got some double bonds in there also, and all the hydrogens can branch off from either side. So we get chains and rings. We're going to be looking at chains for the rest of this video, and we're going to be looking at how the different sizes affect the properties. So let's have a quick look at that. So the size, when we talk about size, talk about the length of the chain. Let's just draw some examples to show some different length hydrocarbons. These get a little bit longer all the way through. There we go, we've got some different sizes, small one at the top, large one at the bottom. And if these were all jumbled up together, we'd have some intermolecular forces between these, holding them all together. These are really weak, these forces, but if you have lots of them, then that strength builds up. So the ones that are longer have more intermolecular forces holding them together, and it would make sense to say that it takes more energy to overcome all of these forces. Say for example in this largest one at the bottom, it's got more intermolecular forces than all of the others, so it would take more energy to free up this molecule away from others. Again, conversely, this is the smallest one, only 2 intermolecular forces. This would require less energy to break this molecule away from the others compared to the larger one. So the size and therefore the properties are all linked back to these intermolecular forces. So let's have a quick look at the properties that we're talking about. The first one is to do with boiling point and melting point. The smaller ones very simply have lower boiling points. The larger ones have higher boiling points. Again, this is all linked to those intermolecular forces. More energy is required to overcome the forces, so the temperature has to be higher. We can also look at how viscous they are. This is to do with how easily they flow. So the smaller ones are quite runny, they flow very, very easily, and we'll describe these ones as quite thick. Okay, so the viscosity actually decreases as you move along. Okay, they become less viscous. Viscous means that they flow very, very easily. And the final one is to do with how flammable, just about fit that on, just how flammable they are. The smaller ones burn very, very easily, and as you go along it gets more and more difficult. All of this is important because we want to decide which one's the most useful as fuel. So let's have a look. We want something that would work at very, very low temperatures, so we want something with a low boiling point. We want something that will flow very, very easily, so we want it to flow through pipes and tubes from, say, a tank to the engine very, very easily. So we want something that's runny, and we want something that's going to burn very, very easily as well. So the most useful of all of these sizes to use as a fuel is going to be the one with the low, is the smaller ones. And again, it's all linked to these intermolecular forces. So the larger the molecule is, the less useful it is as a fuel. So a quick reminder then, as a starting point, smaller ones are the ones we want to look at. These are actually in, there's more demand for these. Everyone's after the small ones in terms of getting them as a fuel. Why do we want that to happen? Well, we want it to flow. We want it to ignite very easily, and we want it to work at low temperatures as well. Imagine a car engine not working on a really cold day because the fuel that you use has got a really high boiling point or melting point. So these properties are really important then to make fuels, and again there's a relationship here between the size of the molecule, the number of intermolecular forces, and the amount of energy that's required to overcome these forces, and that will affect melting point, boiling point, viscosity, and flammability.